Welcome to the Weather and Planetary Science channel with Mr. G. And today we're going to answer a question about cold weather and sunny skies. Some people have asked me, why is it always that our sunniest days in the winter are often our coldest days? Well, that has to do with boundary layer dynamics. And the boundary layer is that layer of air just above the Earth's surface to about the 1 kilometer level. The sun's radiation hits the Earth's surface and begins to warm the ground. Those air molecules begin to move around and they tend to rise as they are warmed up. As warm air is more buoyant, it rises. But when it's cold, the air tends to sink and subsides. So when you have subsidence, the sun's radiation is not able to warm the Earth's surface. Usually what we see in here in the upper plains in the winter, as the sun's radiation is much weaker because the Earth's tilt in the winter has the northern hemisphere tilted away from the sun. So the sun's radiation is not strong enough to heat the Earth's surface. So we get that really cold air. The reason very cold days are so clear has to do with where the air is coming from. And of course it's Arctic air, so we know it is cold to start with. So it really deepens in the Arctic where there's no sunshine. When it starts making its way down, it does modify somewhat as it comes along. But at night, when it's very clear, just because of the subsiding motion in the atmosphere, we get clear skies with high pressure systems, at least the ones that come from the Arctic. During the day, the Earth absorbs radiation from the sun. That's why we get warmer temperatures during the afternoon, but at night, the Earth releases that into the atmosphere. And that allows us to cool. So if the skies are clear, it all goes off into space. This is why even a little bit of clouds, when it's that cold, will make a difference. The cloud is like a little blanket that keeps the heat closer to the Earth. The most important reason is that cold air holds very little moisture, which allows for the skies to be very clear. Sometimes there are temperature inversions that does allow for a layer of haze to form. As you can see in this photo, an example of cold day, clear skies. See how bright the sun is. Even though the sun angles are much further south in the winter, but because the only thing in the air is the air molecules, you don't have dust particles, you don't have moisture, you don't have other chemicals in the air, it doesn't diffuse any of the sunlight. See, typically when you add other elements into the atmosphere and we're looking at the sun, as you see it, sometimes the sunlight gets diffused. So some days don't look as bright as others. But when there is no inhibitions in the atmosphere, that makes the sun looks brighter, looks more defined, even in the winter in the northern hemisphere, at least the far northern, in the polar regions. So that is one of the reasons why it looks like that. Now here is an example of the haze. This is an example of what you see in the inversion layer. You see that haze. You see how it looks kind of cloudy. From the surface down up, you say that inversion layer usually is going to be about 2 or 3 kilometers up off of the surface. And it's just a layer of warm air that's trapped in between two layers. It's sandwiched in between cold at the surface and cold aloft. So there's just enough space for some haze to form, and in that area is where you'll see moisture, dust, and other chemicals that may be in our atmosphere. And here's one other thing that you'll see. Here's a look at what we mean by the density of the atmosphere. If you're down on the surface, the air is much dense than it is, say, at the top of the mountains or where planes fly up at 30,000 feet or 40,000 feet. The air is much thinner. This is why planes have to fly so fast, or else they'll fall out of the sky, because they have to keep enough air going over their wings in order to stay airborne. And here's the final thing that we're going to talk about today is atmospheric illusions that take place because of the dryness in the atmosphere. Since there's very little moisture, and sometimes the inversion layer will have high cirrus clouds. Maybe you might see wispy cirrus clouds, which is probably the layer of clouds that you see on Neptune. But anyway, but those cirrus clouds filter sunlight, and sometimes the sun angles comes in certain directions. You see that reflection, some of that light from the sun gets reflected in different directions, and it comes in at different wavelengths, so it appear to be in different colors, and it will create that ring because you're seeing the sun's light being dispersed in different directions by those water droplets in the upper levels of the atmosphere, and it creates those beautiful sundogs that we often see here in the upper plains during the winter months. Well, that'll do it for this video. Thanks for watching, and I hope that this was educational. Please remember to subscribe to the channel and to leave a like, and also leave your comments of what you thought of this video. And if you have any weather questions or science questions about the earth or geology, the rocks, or anything of the lithosphere or anything like that, any science questions about earth science that you may have that you would like me to make a video for, just leave your question down in the comments and I'll take a look at them and see if I can produce something for you. Again, thanks and have a great day. See you in the next video.